G'day guys, today's video I am going to be going through with you the steps of making your own basic battery discharger / battery killer. Now first of all, I want to make it quite clear that this isn't my own idea. This is actually an inspiration I got from another video channel who showed how to do this, but it does explain it a little bit more in depth. And it was by another channel called RC Video Reviews. So the reason why I'm doing this is just to show you how to do it as well, but I also need to make a battery discharger. Reason being is I've got some battery chargers and they're really good chargers. The problem is when it comes to discharging, no matter how much you program the discharge amperage, say for instance 5 amps for argument's sake, doesn't go above 0.2 amps, and that's really frustrating because then it's just discharging for hours on end. And you know, like that saying, ain't nobody got time for that. Also, it comes in handy too if you have a Lipo battery that has reached the end of its usable life and you need to dispose of it. So what I'm going to do is we're going to cut across to the bench and I'll show you what we have and what needs to be done. Alright guys, so what I have here are the component, probably 90% of the components required to assemble this. Now, the main part that we need for making a discharger are resistors. So what I have here are two 100 watt 8 ohm resistors. Now what these do is these create resistance, which causes amperage, which causes discharge, and this is what we need. This is what we'll be using, or what is required to discharge a battery. One of the other things we will need are a voltage step down device. What this does is it drops voltage down to a set voltage. So for instance, I have here a fan that runs on 12 volt, and so it will allow no more than 12 volts to pass through it. That way we won't burn out the cooling fan. You'll also need some wire to connect the batteries. We need some smaller gauge wire for the fan and step voltage step down. Now, when you have current going through the resistors, they will get hot. They will get quite hot. So we'll need a fan to cool it down. I did have some other fans coming, but they've taken forever to come from China. So the fan will help with the cooling. I have here an old PC CPU heatsink that will help with dissipating heat. We'll also need, now this isn't really absolutely necessary, but it helps. And I have here some thermal paste, which will help with heat transfer. You'll also need some screws. Now, depending on how you go about connecting all using the hardware for connecting it to whatever will determine on what kind of screws you will use. Other things you will need are some wire cutters and strippers. You will need a soldering iron and solder and so forth, and also you will need a plug. Now I've chosen a XT60 plug, and you can, if you have different kinds of batteries with different plugs, you can make little adapters and so forth. It's entirely up to you. Also, if you're going to use this as a discharger, I also recommend that you use a voltage alarm. Now this one here I got off eBay, cost me about $7. And this one you can push a little button here, and what that does is it can set the voltage alarm when the alarm cuts in. So for instance, if you're going to storage charge, it'll be 3.8 volts per cell, so you would push the button until it says 3.8 volts, and then when you connect it to the discharger, it will you connect this to your balance lead on your battery, and then it will sound the alarm when it's discharged down to 3.8 volts per cell. But if, for instance, you have a old battery like this that is past its use by date and has a broken balance lead, this will also be used as a battery killer. It will just completely discharge the battery until the battery has no voltage left. So we will be using this battery at the end of this when this is assembled. So what I'm going to do, guys, is I'm going to set the camera up and I will go through with you the steps of assembling this. Alright guys, so I have my soldering iron here just heating up. I got everything necessary for it, and just bring it over here. So one of the things we'll need to do first is get our little voltage step down device set up. And if you're unfamiliar with one of these, as I said, what this does is, say for instance you have a 12 volt fan. Well, if you have a 6 volt 6 cell LiPo, a 6 cell LiPo is over 20 volts, and if you need to discharge it, well, it'll discharge, however you'll have over 20 volts going through the fan. It's going to be spectacular for a few minutes, but you'll probably end up burning out the fan. So what we need to do is start getting some wires soldered on. Now, when you are setting this up and getting it ready, take note. Each manufacturer has it set up a little bit different, but take note on the underside of voltage direction. So it has, in this case, it has an arrow, and it's telling that the voltage, in voltage and out voltage, so it's going that way. So we've got to make sure our in voltage is where the maximum voltage goes in, and the out is where the minimum set voltage goes out, obviously. So let's get this all set up. So okay, so we'll get don't need tons of wire. I'll try and get most of it in on camera as I can. So we've got our positive and our negative, and we'll have this set up so it'll go straight onto the plug here. So now, you don't necessarily need flux, but it does help. So I just like to put a little bit on the solder, or solder, for my American friends watching this. The flux just really just helps keep it clean. There we go. Same for the step down wires. Oop. There we go. Alrighty. Bit more solder. It's making all kinds of weird noises. Alright, now the next part is get these wires on. What I'll do is I'll just do it off camera and I'll show you the finished bit after that. Alrighty guys, so I have the plug on, I have the 4 wires connected to the plug, so we've got the main wires and we have the smaller wires for the step down converter. So what I'm going to do is, so I'm not spending ages filming, I'll just show what's next in the setup, in the process, do it off camera, show you it completed, then we'll move on to the next step. So now the next step is to get the step down converter wired up. So what I'll have to do is tin the terminals and then I will connect it to the wires and then we'll proceed from there. Alright guys, so here we have the step down converter wired up. Now always make sure that you not only pay attention to voltage direction but the polarity. So take note of negative in and positive in, and it'll be exactly the same for out, positive out and negative out. So what we'll do, like I'm not going to use all this wire, so what I'll do is I'm going to measure the length of the wire for the fan and then use that to give a rough estimate how much wire I need to cut off. So then I will cut off the excess wire that isn't needed and we'll use that for connecting the resistors. So I'll be back with the next step. Alrighty guys, so now what I've done is, so now the whole circuit setup for the fan is completed. So got the wires all soldered to the step down converter and I have measured the length of main wire that I need. Now the next part is important, because what we need to do now is I'm going to mount the resistors to the heatsink, which will require some screws. Now, like I said, depending on how you want to do this, it will be up to you. Like I said, I'm using this old CPU heatsink. The fan will be going underneath. What I'll do is I will glue on some like little rubber steps so it's off the ground and it can suck air in. But it'll have heat sinks on top here. The resistors will be on top of the heat sink, so the heat will be going through here. So this is where the thermal paste comes in. Like I said, it's not imperative to use this, however it does help with heat transfer. So what I'm going to do is I'm going to mount these onto the heat sink, then I will be back, and then we'll be back with the next step. Alright guys, so I have the two resistors mounted to the heatsink. I have used the thermal paste, probably, I don't know if you can see it, and there's where it's squeeged out a little bit under pressure. So it just got a couple of screws to mount them on. I have connected them together, so it's just some wire soldered on. So now the next part is to connect the main wires to the resistors. Now, unlike a diode, resistors aren't polarity sensitive. All they do is just create resistance. So what we'll do is I will, off camera, set up, basically do the last bit. So I will connect the wires to the resistors and I will mount the fan underneath. So when we come back, we'll have the final bit and we'll go from there. Alright guys, so essentially this thing is finished. It is ready for use. So to go over again, so we have our plug, we have our main wire, secondary wire for the voltage step down converter, which runs the fan here. We have our heatsink, and we have our 100 watt 8 ohm resistors. So to give you a quick look up close, so as we see, the resistors are mounted directly onto the heatsink. The fan here, it looks a little bit messy, as I tried to use a bit of zap kicker just to glue these old plastic bushings to the fan here. Yeah, it just got a bit messy, but the fan is mounted to the underneath of the heat sink. So essentially, as it runs, it just sucks up air, blows air onto the heat sink, which is then transferring, getting the heat out away from the resistors. So what we're going to do is we're going to go outside for obvious reasons. We are going to test it on the this old battery here, and what I will do is I'll film the initial start of it and pause and come back and see how we're going. So what we'll do is we'll take this outside and hope for the best. Alrighty guys, so I'm not sure how this is going to go. I've got it set up outside. If something were to happen to the battery, I can at least quickly disconnect it and chug it out into the front yard. Going to keep an eye on the temperature, and unfortunately I can't give you voltage readings because as I showed earlier, the balance lead is busted. This battery is old. So what we're going to do is we're going to connect it up and hope for the best. get ready for a bang. Alright, well, fan's spinning. I'll put the battery over here for obvious reasons, away from the camera. And so far so good. I am going to tidy this up later on. I can feel a little bit of warmth, fairly warm. So what I'm going to do is I'll pause the camera here, and I will periodically come out and check the battery and check the resistors and so forth, and I will record if there's any sudden changes. Sorry for the traffic noise, I do live on a busy street. So yep, I will pause here, I will come back if there's any change, but that'll be through the magic of video editing. Alrighty, so it's been a while, not sure how, it's probably been about an hour and a half maybe. The resistors are not even, barely even warm. The fan has stopped. Now, I don't know if the fan has burnt itself out, I honestly don't know. However, I can't find my multimeter anywhere. So what I have is this Toolkit RC battery charger. It also can give you a voltage readout if you just plug the battery into the, what do you call it? Just plug it into where you plug your battery in to be charged, because that's your power in, that's out. So what I'll do is I will just have this, hopefully, oh, there's my ugly mug and the reflection. Alright, so I'll just disconnect this to see. The battery is warm, but you know, you've got the power, so we'll see if it powers up. Well, there's no power, so I can only assume that the battery is completely flat. It hasn't puffed or anything. I'll just plug it into here to see if this, no power into there. Alright, so what I'm going to do is I'm trying to find my voltage meter. So what I'm going to do, guys, is I'm just going to pause it here and I'll be back. Alright guys, so I can't find my multimeter, so what I've had to resort to is getting my battery charger out. So what I'm just going to do is we will connect it, and just hopefully I can, just hoping that it reads what the screen can pick up. So it's interesting. It's saying 4.32 volts. That is odd. This battery should not be charged. Okay, that's strange. wait a minute, that's 4.35 volts total, not per cell. So it is at 4 volts at total voltage. Sorry guys, I had a complete and utter brain fart. So it's at 4.3 volts total voltage out of a 2-cell pack. So what we're going to do is stick it back on the discharger and we'll be back. Well guys, so far it's almost dead flat. So not sure if you can see it on the screen, but it is, well, nearly about 2 volts. So honestly guys, that's as much as I'm going to record, but as you can see, this has worked very well. I'm probably going to hook it up for a little bit more just to try and discharge it a bit more, but that has worked very well. I'm quite happy with the results. So guys, if you want some information on where I got the parts from, or where you can get the parts from, don't hesitate to comment. And until then guys, enjoy your hobby and cheers.